Hello students, in this video we will be discussing about projectile motion. Now, what happens student, if we throw any object vertically upwards, what happens, the object follows a path and it comes back to the surface of the earth after traveling a certain distance. And let us consider this is the horizontal plane on which the object will be falling. Okay, this is the horizontal plane from where the object has been projected upwards, and this is the vertical direction of the movement of the object. So let us consider this is x-axis and this is y-axis. And also students, let us consider the velocity by which the object has been projected upward or it has been thrown upwards. Let us consider it is u, and the angle made to the horizontal surface is theta. Here what will happen, the object is following two paths. One, it is moving in the x direction, in this direction, and also it is moving upwards, that is in the y direction as well. Here in x direction, we know the vector quantities can be resolved in two components, one along the horizontal direction and one along the vertical direction. Here students, the velocity, we know it is a vector quantity, therefore the velocity of the object along the horizontal axis will be u cos theta, and the velocity of the object along the vertical component will be u sin theta. We know this is the velocity along the x-axis and this is the velocity along the y-axis that we have studied, that we have considered. Let us consider this is the time. Let us consider this is the initial time 0 seconds when we are projecting the object, and after some times when the object is reaching to the surface of the earth, let us consider this is time t. This is the total time t from projecting the object upwards and the object reaching to the ground. Let us take the total time be capital T. Okay. Here students, this distance along the x-axis, let us consider this is the distance which is x. Okay. We know the distance traveled is equals to velocity multiplied by time. Along the x-axis, what is happening? The velocity of the object is u cos theta, and the time, let us consider this, the time taken along the x-axis is small t. From here students, we can find t is equals to x upon u cos theta. Let us take this is equation 1. Clear? This is equation 1. And students, the object we have studied, that we have discussed earlier, that the object is also moving towards the y direction. So along the y direction, we know that from Newton's equations of motion, that is displacement s is equals to ut plus half at square. For vertical components, let us consider the displacement is y and the velocity along the y-axis is u sin theta multiplied by t. Let us consider it is again t, because obviously the object has been thrown the vertical direction and the horizontal direction. Both are taking the same number of time now, because we are having only one object. If it is taking 10 seconds to reach here, and obviously for in the y direction, it is also taking 10 seconds to reach over here. Okay? Now here, plus 1 by 2 at square. A in this place we will take, when the object is moving upwards, we take the value of g as negative. So we have to put minus of g multiplied by t square, that is theta square. From here we can find y is equals to u sin theta, and earlier in equation 1 we have found the value of t, that is x upon u cos theta. And here plus minus becomes minus of g upon 2, and the value of t, that is x upon u cos theta ka whole square. Clear? So similarly we can find here u and u gets cancelled. So y is equals to sine upon cos, that is tan theta multiplied by x minus g upon 2 u, this is x square, upon u cos theta ka whole square, which can be written as u square cos square theta. So students, we have got an equation. This is the equation which is similar to the general formula of equation of parabola. The equation of parabola says y is equals to ax plus of bx square. This is the equation of parabola shaped. Okay, parabola shape. And similarly, for this projectile motion, we have found this equation where a is equals to tan theta and the value of b is equals to minus of g upon 2 u square cos square theta. So this is, from this, if we compare the equation of projectile and the equation of parabola, we got that in projectile motion, when the object is projected upwards, the object follows a path, and that path is in the shape of parabola. From here, students, we will also find the time of flight. Time of flight means how much time the object is staying in the air from initial to the final time, and we will also find the maximum distance, how much distance it is moving in the upward direction, that is along the y-axis, and also we will find the total distance along the x-axis, which is known as range. Okay, students, now we have found the equation of parabola or the motion of the path, projectile motion. Now we will find the time of flight. Time of flight means total time taken by the object to stay in the air, that it is staying in the air for some times, and that we will be finding now. Now students, first of all, we have to understand that always the time of flight is always calculated, always decided by the vertical motion. Vertical motion means how much time it is staying in the y-axis. Now, we are talking about the time of flight. Time of flight means how much time it is taking to stay in a position above the Earth's surface. Any position above the Earth's surface is along the y direction. This is the y direction and this is the x direction. Obviously, so that is why we will be finding the time flight from the vertical motion. So it is decided by vertical motion. Always remember that the time of flight is always decided by the vertical motion of the object. Here, let us consider when the object was thrown initially at time t, it was moving upwards, and after some times when the final velocity here became 0, here it was 0 at the maximum height. It was 0, and then again it is coming back to the initial position. Here the displacement is how much? It is starting from the same point and coming back to the same point. Therefore, displacement is equals to 0. This is what we are considering about vertical motion. Okay? The vertical motion. Here, students, initially we have considered the velocity along the y-axis. The velocity along the y-axis is equals to u sine theta. We have considered it. This was initial. This is initial velocity. Okay? Initial velocity. And when the body is moving upwards, we take acceleration due to gravity as minus of g, that is negative of g, and the displacement we have considered it to be 0 because it is moving upwards, and again it is coming back to the same position. And here the time taken, we have considered the total time taken is, let us consider capital T. So here we are considering capital T. Now from the second equation of motion, we have, what do we have? That is S is equals to ut plus half at square. Take it? Now here displacement is obviously 0 and equals to u ka value that we have considered as u sine theta and multiplied by t, and t ka value we have considered capital T. Here it is capital T, plus 1 by 2 acceleration due to gravity is minus of g, and t ka square, that is capital T ka square. students, if we take t common here, t and t, one t gets cancelled like this. If we take one t common over here, what we are left with? U sine theta minus of 1 by 2 t. Sorry, gt. Clear? And t comes here and becomes 0. So finally we are left with 1 by 2 gt. If we take this on the left side, this negative becomes positive sign over here, and this becomes u sine theta. Clear? Now students, now from here t will be equal to how much? T, this is capital T, sorry, I mistakenly wrote small t, this is capital T. When we find the value of this t, we get it is equals to 2 u sine theta divided by this g comes down, g multiplied by 1 comes here. So this is the total time of slide of the object in projectile motion. Thank you very much for watching the video.